Whether you are planning your absolute dream home, prepping for a high-stakes real estate meeting, or you just love understanding how things actually work behind the drywall, this deep dive is going to fundamentally change how you look at houses.
Oh, absolutely.
Seriously. You're going to walk through neighborhoods entirely differently after this.
You really will.
Today, we are looking at excerpts from the 2026 Florida Residential Construction and Renovation Strategic Guide.
Well,
And our mission today is simple but crucial. We are going to decode the chaotic, incredibly expensive world of construction and really arm you with the ultimate pre-project knowledge.
Right. And it is so important to get this right because we have to establish a foundational rule straight out of the gate here.
Let's hear it.
Construction projects do not fail because someone picked the wrong kitchen backsplash.
Right, or a weird paint color.
Exactly. They derail entirely because the overarching scope, the permitting paths, the hidden site conditions, and the material selections they simply were not understood early enough.
Yeah.
It is always the invisible things that sink the ship.
Okay, let's unpack this. Starting with the first major hurdle. We can call it choosing your hard, because the 2026 data breaks down 4 distinct project types. And each one comes with its own specific set of rules and roadblocks.
Yes. Pick your poison, essentially.
Exactly. Let's start chronologically with the dream for a lot of people. New builds, ground-up construction.
Big one.
Right. The massive appeal here is obvious. You get a completely blank slate.
Yeah.
Total layout freedom.
You do. You get a blank slate for the design, yes, but here is the reality check. The physical site and the local approvals become your biggest, most unpredictable variables.
Yeah, you can't just build a castle anywhere.
Right. Before you even get too far into sketching out your perfect floor plan, you have to verify a massive list of constraints. The very first is zoning and use. You have to know exactly what you are legally allowed to build.
And what does that actually look like in practice? Because I think people assume if they own the dirt, they can build whatever they want on it.
Not even close. I mean, you have to understand your setbacks, for one. Yeah. Think of setbacks, like invisible force fields drawn inside your property lines. You might own a 100-foot wide lot, but if the city requires a 20-foot setback on each side, you only have 60 feet of buildable width.
Wow.
Then there are maximum height restrictions and your total lot coverage limits.
Lot coverage limits.
Yeah, meaning the city will literally tell you that you cannot pave or build over more than, say, 40% of your total land.
That is wild. And it doesn't stop at the property lines either. One of the things in these strategic documents that stood out to me is the focus on how the house actually connects to the grid.
Oh, the utilities.
Yes. You have to check your utilities immediately. Like, are you tying into a city sewer system, or will you need to bury a massive septic tank in the yard?
Which takes up a ton of space.
Right. And what does the water service look like? Is power readily available? And crucially, what is the electrical service size coming to the street?
Exactly. Because finding out your utility service is undersized leads to incredibly expensive forced upgrades.
Just to get the lights on.
Just to get started. And then you have the literal ground you are standing on. Site conditions like natural drainage, soil quality, or the need to truck in hundreds of loads of fill dirt that can completely alter a foundation plan.
Yeah, and because these documents focus heavily on Florida's unique environment, flood zone requirements are a massive, non-negotiable factor.
Huge.
Let's talk about that, because the phrase finished floor elevation comes up constantly in the text. What does that actually mean for the homeowner's budget?
Well, finished floor elevation is the legally mandated height your first floor must reach to be considered safe from flooding.
Okay.
So, if your lot sits at 4 feet above sea level, but the flood zone rule dictates your house must be at 10 feet, you have to make up that 6-foot difference.
Oh, wow.
You are either bringing in a mountain of dirt, or you are building your house up on tall concrete blocks or pilings.
Which changes everything.
It dictates the number of stairs you have to climb every day, the slope of your driveway, and it takes a huge bite out of your structural budget.
So based on the text, the ultimate checklist question you need to ask your design team is, what site factors could change the budget after design begins?
That is a phenomenal question to ask.
It forces early investigation.
Exactly.
So that is the reality of starting from a patch of dirt. But what if you already have the dirt and the house, and you just want to build a guest house in the backyard?
The ADUs.
Yes. Let's talk about the second project type, the massive boom in ADUs, or accessory dwelling units.
This is a huge trend right now. We are talking about detached backyard cottages, attached mother-in-law suites, or conversions that act as a secondary living space.
Right. People want a spot for aging parents, or maybe some rental income.
But you can't just drop a tiny house in your backyard and call it a day.
But wait, what if I just go online and buy one of those pre-designed standard ADU plans for a few $100? Doesn't that bypass a lot of the headache?
That is actually one of the biggest gotchas in the industry right now.
Really?
Yeah. People buy a standard ADU plan online, but those almost never perfectly fit local setback and coverage rules.
Oh, because of those force fields we just talked about.
Exactly. You take that plan to the permitting office, and they tell you it is 3 feet too close to the property line, or it puts you over your lot coverage limit.
So you have to redesign it anyway.
You end up having to pay an architect to redesign the cheap plan you just bought.
That is incredibly frustrating. And the utilities seem like a massive puzzle here, too.
Oh, they are.
The text mentions you have to figure out if you are legally allowed to share meters with the main house, or if the city forces you to install separate utility meters.
Which is not cheap.
No. If you have to dig up the street to upgrade your main home's sewer line just to handle a new backyard bathroom, your budget is going to explode.
It escalates so fast. Which brings us to a very common scenario you see everywhere, converting an existing garage into an ADU.
Oh, yeah. People assume it is cheap. Just throw up some drywall, add a toilet, and you are done, right?
I mean, that is exactly what it looks like on television. But physically, it is rarely that easy. Think about a garage. The concrete slab is usually sloped toward the door so water can run out.
Oh, I never thought of that.
Yeah. It is often sitting lower than the main house, which means it might not meet those strict flood elevation codes we just talked about.
Interesting.
Furthermore, there is usually no vapor barrier under a garage slab to keep moisture out because it was designed for cars, not carpets.
So your floors get ruined.
Exactly. Add in the existing ceiling structure, new insulation requirements, proving you have proper escape windows for sleeping areas, and entirely new utility routing through solid concrete. It is a major engineering project.
It is a lot more than just putting down a rug and a couch. All right, the third project type. Additions. Expanding the footprint of the main house.
What's fascinating here is that homeowners often view an addition as simply building another room. Like they say, I just want to stretch the living room out 10 feet.
Sure, just pull the wall out.
Right. But best practice dictates you must treat an addition as a complex structural project first and a finished project second. The real drivers of cost and complexity come from how you marry the new structure to the old structure.
Because you're essentially colliding two completely different eras of building codes together.
Precisely.
Yeah.
You have to match or transition the foundation types. What if your 1950s house is built on a raised crawl space, but you want the new addition to be a concrete slab poured directly on the ground?
It's like a nightmare.
Connecting those two different systems so they do not shift and crack apart takes serious engineering. And then there are the roof tie-ins.
The roof tie-ins sound terrifying.
They can be.
The data shows that when you add a new roof line to an old one, you are creating new valleys and slopes. If you get those angles or the drainage paths wrong, water just funnels directly into the center of the house during a rainstorm.
Exactly. And let's not forget the hidden math of structural engineering. When you add on, you are placing new structural loads, the physical weight of the new roof and walls, onto old framing that was never designed to hold it.
Which is scary to think about.
And the mechanical rework is intense. You have to evaluate if your current air conditioning unit can even handle the extra square footage. Can your electrical panel handle another bedroom and bathroom, or do you need a completely new service upgrade?
And there is a huge human element to additions that people severely underestimate. The living in place logistics.
Oh, the dust.
Yes. If you are trying to live in the house while they build, you have to plan for extreme dust control, restricted access, and potentially setting up a temporary kitchen or bathroom in your hallway for months.
It is incredibly disruptive.
Which leads us to the fourth and final type. Full renovations, just gutting the inside of the home and rebuilding it.
This delivers the biggest visual transformation, but it absolutely carries the highest amount of unknowns. You are tearing into walls that have been hiding secrets for decades.
This section of the text is dense. It breaks renovations down into 4 high-impact categories. Let's walk through them. First is layout changes. The documents say moving walls means dealing with new openings and headers. For the listener who isn't a contractor, what actually is a header?
A header is a beefy, heavy-duty structural beam that goes horizontally over a new doorway or window.
Okay.
You can't just swing a sledgehammer and knock out a wall. If that wall is holding up the roof or the second floor, you have to install a header to carry all that weight across the new opening so your ceiling doesn't cave in.
Makes sense.
It requires temporary supports, engineering, and a lot of labor.
Got it. Okay, the second category is systems. meaning pulling out the old guts of the house and updating the electrical wiring, the plumbing pipes, the HVAC ductwork, and the ventilation to modern standards.
Right. You might open a wall and find ancient, dangerous wiring that legally has to be replaced once exposed.
And the third category is envelope upgrades. The envelope is the outer shell of your house. This means installing new, impact-rated windows and doors, updating the flashing, which is the specialized metal or tape that seals the gaps around windows so water can't get in, and modernizing how the house sheds water.
Which is vital.
And the fourth category is resilience, which ties into the envelope. It means bringing in modern moisture strategies and wind-related detailing so the house can actually survive a major storm.
Exactly.
The golden rule of thumb from the 2026 guidelines. The older the home, or the more prior DIY repairs it has seen, the more important documentation and inspection readiness become. You are going to find problems.
That is a crucial point. It
Yes.
transitions perfectly into one of the biggest misconceptions in this entire industry, the timeline.
Yes. The reality check here is that construction does not start at the signing of the contract.
No.
So many people think, I just signed the paperwork, gave them a deposit, where are the hammers? Why isn't anyone at my house?
Because design, permitting, and material selections form their own distinct, heavily involved phase. Permitting is a phase, not a starting line.
Right.
And it is a phase that gets bogged down very easily. The city has to review every single detail of your plan to ensure it won't collapse or catch fire.
Reading through the section on permit roadblocks, it is wild how fast things can stop. The most common delay is simply incomplete plans.
Yes.
But another major roadblock comes from missing engineering triggers. If your renovation includes opening a wall, changing a roof line, or adding square footage, that triggers a legal need for formal, stamped engineering sign-offs.
Furthermore, Florida has state-specific product approval gaps.
What does that mean?
The state requires highly formalized, tested documentation for certain building components like windows, doors, and roofing materials before they will legally let you install them.
So you can't just buy a window at a hardware store and put it in.
No, the permitting office will almost certainly have comments and require changes to your plans, so you must mentally build time into your schedule for a revision cycle.
But the text offers a brilliant solution for the one delay you actually have total control over: your own choices.
The decision deadline list.
Yes, they suggest building a decision deadline list. You take all the major items, cabinets, windows, exterior doors, plumbing fixtures, the exact tile you want, and you attach hard, non-negotiable dates to them.
It works wonders.
If you don't pick your bathtub by March 1st, the entire project timeline pushes back. It keeps everyone, including you, accountable.
It forces decisions to be made.
Here's where it gets really interesting. Let's talk about the environment itself. The guide outlines Florida's big three: moisture, wind, and foundations.
The big hitters.
This is highly technical stuff, but it is literally the difference between a house that lasts a century and a house that rocks from the inside out in 5 years. Let's start with moisture management, which the source explicitly calls the silent budget killer.
Because of the intense humidity and driving rain exposure, water detailing is completely non-negotiable. We mentioned flashing earlier. If you do not properly tape and flash the intersections where your roof meets your walls, or around every single window, water gets behind the siding.
And you won't even see it.
Exactly. And when water gets behind the exterior, the wood framing decays invisibly. You won't know it is happening until the wall is entirely rotted out. You also need correct waterproofing systems in all your wet areas, like showers.
And it is not just the house, it is the land around it. You have to grade the site drainage so bulk rainwater moves away from the foundation.
Vital.
But the detail that blew my mind was the HVAC system. You always hear about sizing an AC unit to keep the house cool, but the text says you need an HVAC design that specifically supports humidity control.
Yes.
Why is that distinction so important? Doesn't cold air automatically mean dry air?
It does not, and that is a massive misconception. If your air conditioning unit is too big, which contractors sometimes do, thinking bigger is better, it blasts the house with freezing air and drops the temperature in 10 minutes.
Okay, sounds good so far.
Then it shuts off. But because it only ran for 10 minutes, it didn't have time to extract the humidity from the air. You end up with a house that is 68 degrees, but damp and clammy. Over time, that indoor humidity causes mold to grow on your furniture and inside your walls.
That is terrible.
You have to ask your team, what is the plan to control bulk water, vapor, and indoor humidity?
That brings us to the second of the big three: wind and opening protection. Obviously, in hurricane-prone areas, this is vital. But I was reading this section on modifications,
Yeah.
and it says even if you are not physically changing the windows, your project decisions can still drastically affect the building's wind performance. How does that make any sense?
It comes down to something called load paths.
Load paths.
Think of a load path like a continuous, invisible seatbelt that holds your house together. It is a series of structural connections that transfer the immense pressure of heavy winds from the roof down through the framing of the walls all the way into the concrete foundation.
Like a structural chain.
Exactly. If you change a roof line, or if you cut a new hole in a wall for French doors, you are severing that seatbelt. You are altering how the wind forces travel through the house.
So you have to re-engineer that seatbelt around the new doors.
You do.
You always have to ask, if we modify openings or roofs, what changes are needed to keep the structure durable and compliant?
Always.
All right, the third environmental factor, foundations and slabs. Specifically, the slab-on-grade foundation, which is basically a flat layer of concrete poured directly on the dirt.
These can hide incredibly expensive surprises. It is essentially a concrete mystery box under your feet.
I think about people buying flipped homes. They walk in, see beautiful new luxury vinyl flooring, and think it is perfect. But if they didn't inspect the slab beneath it first, they could be buying a ticking time bomb.
Absolutely. Once you crack into a slab for renovation, you might find cast iron drain lines that have completely rusted away into the soil. You might find broken plumbing vents or shoddy prior repairs that were just paved over with cement. You might discover serious settlement cracks that cause the floor level to dip drastically from one room to another.
There's also the threat of vapor migration. If the original builder didn't put a proper plastic vapor barrier under the concrete, moisture from the earth wicks right up through the slab and ruins that beautiful new flooring you just installed.
Happens all the time.
You always need to ask your builder, what conditions would trigger slab work and how would that be documented and priced?
If we connect this to the bigger picture, that question of pricing brings us to the most dangerous part of any construction contract, the budget black holes.
Yes.
Specifically, allowances and unforeseen conditions. Allowances are easily the most misunderstood line item in any renovation.
Let's demystify that. An allowance exists because not every single material selection is known at the time you sign the massive contract. We have all heard the horror stories, right? You know you want a beautiful freestanding soaking tub, but you haven't picked the exact model yet. So the builder puts in a placeholder number, an allowance of, say, $1,000.
But $1,000 might only cover a basic plastic drop-in tub.
Exactly.
If your taste is high-end, but the builder put in an entry-level allowance just to make their total bid look cheaper and win the job, you are going to blow your budget instantly when you finally go shopping.
Exactly. So the 2026 strategy, guys, says a good allowance needs 3 very specific things to protect the homeowner. First, a crystal clear description of what it actually covers.
Yes.
Is that $1,000 bathtub allowance just for the physical tub, or does it also include the plumber's labor to install it?
Right.
Second, it needs a defined quality level. Are we budgeting for entry-level, mid-tier, or luxury? And third, it must outline the exact process for adjustments. If you pick a cheaper tub, how do you get credited back?
You have to demand total clarity. Allowances should never be used to cover core, fundamental scope that should already be defined, like drywall or basic wood framing.
That makes sense.
And you must know if local taxes and freight shipping are included in that placeholder number. The best move you can make is to ask for an allowance schedule that clearly lists every single allowance and exactly how the math will be handled.
But then there are the things literally no one could have budgeted for. Unforeseen conditions. When you are working inside existing walls, floors, and roofs, surprises are guaranteed.
Always.
But the text makes a brilliant distinction between reasonable unknowns and avoidable unknowns.
Reasonable unknowns are the true surprises. Hidden water damage that was entirely enclosed behind drywall where no inspector could see it, out-of-code wiring hiding in the ceiling.
Right, things you couldn't possibly know.
Or structural deterioration, like old termite damage that was completely invisible during the pre-construction walkthrough. You can't predict those. You just have to have a budget buffer to adapt to them.
But the avoidable unknowns, those are entirely preventable. Those come from vague, scout language in the contract where no one actually specified who was doing what.
Exactly.
They come from missing pre-construction documentation, where nobody bothered to map out where the existing pipes were, or they come from having no clear decision trail, meaning there is no written record of who approved what change and when.
Yes.
The ultimate homeowner move here is to ask up front, how will hidden conditions and decisions be documented? Are they using daily photo logs? Are there written change order approvals? Never, ever accept verbal agreements on a job site.
Get it in writing.
So what does this all mean? Let's bring this all together into the ultimate pre-project checklist. Before you spend a single significant dollar on architectural design or contractors, you need to gather these specific items to dramatically reduce those change orders and delays later.
This is the important part.
First, get a survey to verify your exact lot lines, especially if those invisible setbacks are critical. Get your flood zone info. Gather all HOA rules if you live in a community with an association.
Pull all your utility info, too.
Yes, meters, sewer or septic status, and the electrical service size. Next, sit down and write a ruthless must-have versus nice-to-have list. Establish a highly realistic budget range that includes a healthy cash buffer for those reasonable unknowns.
The buffer is key.
Map out a target timeline, but build in real flexibility for the unpredictable permitting process and those material lead times. And finally, define all your physical site constraints. The massive trees you can't cut down, the access points for the heavy machinery, and the property easements.
This is entirely about putting yourself in the driver's seat.
Right.
When you understand the overarching rules of how these projects are actually structured, how the physical environment dictates the structural engineering, and how the budget is assembled behind the scenes, you aren't just crossing your fingers and hoping for the best.
Right.
You are actively saving yourself thousands of dollars and months of absolute headaches.
It is so true. Whether you are building your dream house from scratch, renovating a historic home, or simply trying to understand the realities of buying a flipped property in the real estate market, this knowledge is your absolute best defense.
This raises an important question, though, and it is something for everyone to really think about.
Okay.
If local environments like Florida's intense moisture, hurricane-force winds, and strict flood risks force us to constantly rethink how we attach roofs, how we manage invisible vapor, and how high we elevate our concrete foundations, at what point do we simply stop using traditional wood framing and drywall altogether?
Oh, wow.
Will the standard home of the near future be built from entirely different climate-proof materials that make these current renovation struggles completely obsolete?
That is a fascinating thought to leave on. A completely different kind of house for a rapidly changing world. Thank you so much for joining us on this deep dive. Keep asking those hard questions, look out for those budget black holes, and above all, stay curious.